This example has us determining the median. So a fish and wildlife officer records the weight of trout caught in a lake. Their weights to the nearest tenth of a pound are 2.9, 1.5, 2.8, 1.1, 1.0, 2.7, 3.0, 1.6, 1.9, and 2.3. Determine the median weight. So to determine the median weight, we have to put the numbers in order from least to greatest. When I do this, sometimes you can end up missing one, and then all of a sudden, you started with, let's say, 10 pieces of data, but you finish with only 9, and you don't know which one you've missed. So what I like to do is, as I write them down in my new list, I cross them out in my old list. So when I look, my smallest value is 1.0. So I'm going to write it down, and then I'm going to come up here and just cross it out. My next one is 1.1. So I'm going to write it down and then cross it out. Then I have 1.5 and 1.6 and 1.9 and 2.3 and 2.7 and 2.8, 2.9, and 3.0. So now my numbers, I can see they're all crossed out, so I didn't forget any, and all my numbers are in order. So then I have to find the middle, and sometimes it's really obvious. If you're not sure, start crossing out numbers in pairs. So what I do is I cross out my lowest and my highest, and then my next lowest and my next highest, and I keep going until I have either 1 or 2 numbers left. So 2, because if I cross out 1.9 and 2.3, I have nothing left. So I have to stop there. So my median is here. Those are my middle 2 values. So in order to actually calculate one median value, I have to find the average of these 2 numbers. So I add them together, and I divide by 2. So when I add them together, I get 4.2, and then when I divide by 2, I get 2.1. So the median is 2.1. The B part says, is the median the best measure to represent the typical weight of caught fish? So this one is a really good example because half of the fish caught are below 2.1 and half of the fish caught are above 2.1. So it's good to say that 2.1 is a good middle ground for the weight of fish.